Good morning. Happy Monday. Today is day 134. Our work today is going to continue to focus on linear systems and solving those linear systems. Specifically, we're going to look at one new method, elimination, as a strategy that can help us solve some of these linear systems that we run into. By now, you already should have read through today's objectives and key terms. That's here in this red box, the first page you see each day. Definitely take the time to read through the objectives and the key terms. And you already should have tried to complete some of today's exploratory problems, the purple boxes, with your partner. Now you're on to step 3, analyzing some of your work on those problems before you start working on the blue box problems, the practice problems on your own. We're going to show you one quick thing as we zoom out here for a second. From now on, you're going to start seeing each day in the beginning, use the focus again, exploratory problems to start, part A and B, and then practice problems. But we're going to start splitting this into part 1 and part 2 each day. So there's going to be a couple explore problems where we have a video lesson after you work on your own. Then you'll practice on your own in the blue boxes. Then the more challenging piece of each day, part 2, will come for an exploratory problem again, a purple box problem where we review on video lesson after you practice on your own. And then you'd have a few blue box practice problems that follow that are related to that second exploratory problem, or part 2. So again, this is going to be part 1 here, part A and B, and then we're going to encourage you to pause the video and start working on these practice problems on your own before you finish the rest of the video, which is going to cover part C. So you should have already worked through part A by now. We're going to go ahead and zoom back in here on part A. It told us to consider 2 different equations. This is a system, we could say. For example, there are 2 equations. One is 10 equals 10. We know that's a true statement. The other is 7 equals 7, that down here. So our first job says if you add these 2 equations together, will the resulting equation still be a true statement, and to show your work or explain your answer. So if we take a look at these 2 equations, we'll put this whiteboard in full screen. 10 equals 10 and 7 equals 7. If we were to add these 2 equations together, stack those 2 equations together, it would result in 17 equals 17. If I took the red equation and the blue equation, I add them together, 10 plus 7 on both sides, we see if we add 2 true statements or add 2 equations that are true together, the resulting equation is a true statement. To keep things moving, we were also asked for part 2, if you were to subtract one equation from the other, would the resulting equation still be a true statement? So instead, we'll full screen this whiteboard here again. If we had instead subtracted these equations from each other, if we had subtracted the blue equation from that red equation, each side would now say 3, because each side would say 10 minus 7. We see if we subtract 2 equations from each other, the resulting equation is also a true statement. Why are we pointing this out? Well, if you read the key terms today, and if you read the objectives, you would see that the elimination method is a strategy to solve linear systems that first involves adding together both equations in the linear system. Part A shows us here why if we have 2 true statements, 2 equations, we can add them together, subtract them together, and our new transformed equation is still going to be true as well. That's going to help us here for part B. Part B says, to consider the linear system shown below, the first equation in green is 2x plus 3y equals 20. And the second equation shown in purple is 3x minus 3y, which is equal to 15. Part 1 asked us, if you add these 2 equations together, explain what would happen to the y variable. We see a positive 3y here and negative 3y here. And it says, how could this be helpful if our goal is to determine a common solution to this linear system? So to explore this, it says if you were to add these 2 equations together, I'm going to take a look at our whiteboard. And I'm going to go ahead and show what it would look like if I added this second equation, 3x minus 3y equals 15, with the first equation. So I'm going to stack those together, 3x minus 3y. I'm going to make sure the equal sign is the same spot for both of them. And it says what would happen if we were to add this equation, the purple equation, with the green equation. What would happen to the y variables? And we see here, since the y variables are inverses or opposites of each other, positive 3y and a negative 3y. They're going to eliminate each other. There's going to be no y's left in the equation. So when we think for part 1 about how could this be helpful if our goal were to determine the common solution, we realize by adding these equations together, the y's are going to eliminate each other. Our big goal today, the elimination method, and that's going to leave us with just a one variable equation. Part 2 asked you to find any common solutions or determine any common solutions by using this elimination method, adding equations together, and to show an image of your work. That's kind of what we're going to show here again. So looking back at that equation, when we add them together, 2x plus 3x is going to leave us with 5x. The big key, positive 3y combined with or added with negative 3y eliminates each other. There are no y's left in the equation for now. 20 and 15 get added together. That gives us 35. And we see the big benefit is with the y's eliminated, we now have an equation we can solve for x. 5 times x equals 35. If you're using inspection, you see 7 is the answer. 7 times 5 would give us 35. If you weren't sure, we could have divided both sides by 5 to recognize that. This is half of our answer, half of our common solution. We know if x is 7, we could go ahead and plug that in to either equation. I'm going to plug it into the purple equation just because there happens to be room there still. 3 times 7 minus 3y equals 15. 3 times 7 gives us 21 minus 3y equals 15. And at this point, I should be peeling the onion from Mr. Neville. Subtract 21 on both sides. We're trying to isolate this y or get it all by itself on the left side of the equation here. Negative 3y equals 15 minus 21 should have given you negative 6. And we know 2 times 3 would give us 6, and a positive 2 times a negative 3 would give us a negative 6. So if I solve by inspection, I could see y equals 2. You also could have divided both sides by negative 3. So we believe right now the common solution is x equals 7 and y equals 2. In order to check that, we could go ahead and plug in the 7. 2 times 7 is 14. Plug in the 2. 3 times 2 is 6. So 14 plus 6 really would give us 20. We see that 7 for x, 2 for y works in the purple equation and works in the green equation. That's how elimination helped us get the common solution here. So you'd go ahead and plug in that for your common solution. X was 7, y is 2. Insert an image of your work similar to what I was doing there on my whiteboard. Part 3, which you're going to do on your own, says to explain how the elimination method can help solve linear systems and to think about which types of linear systems work best for this elimination method. So think about how it worked here, the mechanism, what happened to the equations, and why this type of system was a really good system to use for elimination. After that, you're going to work through practice problems on your own now. Problems 1, problems 2, and problem 3 are all going to be built off of what we just discussed there. You should be pausing this video or even closing the tab later on after you work through exploratory problem part C. The second part of the explore problems today, you should come back, unpause this video, and see what we're about to discuss. All right, so welcome back. We're going to take a look now for one last problem. We're going to look at part C on the explore problems. You should have already been spending time today working through problems 1, 2, and 3 on the blue box practice problems. Now, this linear system was more challenging because when we take a look at both of these equations, the first one is negative 2x plus 5y equals 10. And the next equation, 4x minus 7y equals negative 8. We see the challenge, and part 1 and part 2 helped us start thinking about it. Neither one of these equations, negative 2x plus 5y equals 10 or 4x minus 7y equals negative 8, have a variable that's set up to eliminate. The key that you had to recognize, I only have 30 seconds left. We're going to show you this very quickly. If I had multiplied this green equation by 2, everything by 2, it would become negative 4x plus 10y equals 20. You're allowed to do that based on part 1 and part 2. And now when we took this equation, 4x minus 7y equals negative 8, we'd be able to combine these equations and use that elimination method.